This is Bitnar Talks, the engineer takes on construction. Episode 24. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved Document H, Drainage and Waste Disposal. Hi and welcome to Bitnar Talks, your favorite podcast on all matters of architecture, engineering and construction. It is Saturday the 13th of July 2024 and I'm here back with you with the 24th episode and information on Approved Document H, Drainage and Waste Disposal. As ever, before I go to covering material of this episode, let's have a look at what was covered last week. In the last episode, I talked about the Approved Document G, sanitation, hot water safety, water efficiency. Every single time I like to reiterate that the primary responsibility for compliance with building regulations lies with the building owner, followed by those involved in the initiation, design and execution of the work, including principal designers and contractors. On domestic projects, this will be mainly principal designers and contractors though, as we cannot expect the homeowner to know all nitty-gritty about the Building Safety Act and other, but we should do. All parties must be competent and the building owner must enable proper coordination. Generally, and in light of Regulation 8, emphasis is put on a health and safety, but here requirement G2 deals with another subject, with a subject of water conservation. Exemptions from building regulation are detailed in Schedule 2 and Regulation 9 of the building regulations. Key coverage points of the last episodes are the requirement G1 that deals with a reliable supply of wholesome cold water with adequate flow and pressure, avoiding waste and contamination, allowing for alternatives like rainwater or grey water to be used in the property if properly installed and designed. Requirement G2 focuses on water efficiency, setting a standard of 125 litres per person per day for the property or a little bit less of 110 litres per person a day under optional requirements that are being put as a condition of planning application. Requiring calculations for total net water use of the limitation on fittings approach. So two ways of dealing with how much water the building uses. G3 is a requirement that addresses hot water supply, ensuring safe heating and delivery. Systems must have safety measures including thermostats and relief valves. Larger hot water containers, vessels, systems over 500 litres or 45 kilowatts require design by qualified engineers and notification to building control, if unvented. Requirement G4 stipulates adequate sanitary conveniences with hand-washing facilities considering the building type and uses. Houses and flats need at least one water closet with nearby hand washing separated from food preparation area and located at the story of entry to the building. G5 requirement requires a bathroom with a fixed bath or shower and a wash basin in houses and flats and compliant water discharge. And if you do not know on which side you should have your hot water tap, it is left. It is the left side, once and for all. So if your plumber says otherwise, well, he might have made a mistake. So direct him back to G5 requirement of this approved document. Requirement G6 mandates a sink in food preparation area with discharge through proper systems, as ever. Additional hand washing facilities may be required in regulated food hygiene areas. All installations must adhere to approved standards, ensuring safety, efficiency and compliancy in any water system in a building. In this episode, I will move to the approved document H and the considerations of drainage and waste disposal. So without further ado, let's dive into this not so much palatable approved document H. In this episode, I'll talk about the statutory guidance contained within the approved document G, sanitation, hot water safety and water efficiency. This episode will follow its standard format for the material talking about the approved documents. I will first read you the text of the actual regulation and then we'll go section by section dealing with what's required. The document contains guidance for the discharge of requirement H in parts H1 to H6. So let's get into the nitty-gritty of this approved document. Shall we? Starting with the text of the legislation, and this one is pretty long. Longer than the trip to a bathroom, that's for sure. So brace yourself, cause here we go. Foul water drainage. Requirement H1.1. An adequate system of drainage shall be provided to carry foul water from appliances within the building to one of the following, listed in order of priority. A public sewer, or where that is not reasonably practicable. B, a private sewer, communicating with a public sewer, or where that is not reasonably practicable. C, either a septic tank, which has an appropriate form of secondary treatment or another wastewater treatment system, or, where that is not reasonably practicable. D, a cesspool. Point 2. In this part, foul water means wastewater which comprises or includes A, waste from a sanitary convenience, bidet or appliance used for washing receptacles for foul waste, or B, water which has been used for food preparation, cooking or washing. Requirement H1 does not apply to the diversion of water which has been used for personal washing or for the washing of clothes, linen or other articles to collection systems for reuse. Requirement H2, wastewater treatment system and cesspools. Point 1. Any septic tank and its form of secondary treatment or the wastewater treatment system or cesspool shall be so sited and constructed that A, it is not prejudicial to the health of any person. B, it will not contaminate any watercourse, underground water or water supply. C, there are adequate means of access for emptying and maintenance. And D, where relevant, it will function to a sufficient standard for the protection of health in the event of a power failure. Point 2. Any septic tank or holding tank which is part of a wastewater treatment system or cesspool shall be A, of adequate capacity, B, so constructed that it is impermeable to liquids, and C, adequately ventilated. Point 3. Where a foul water drainage systems form from a building discharges to a septic tank, wastewater treatment system or cesspool, a durable notice shall be affixed in a suitable place in the building containing information on any continuing maintenance required to avoid risks to health. Requirement H3, rainwater drainage. Point 1. Adequate provision shall be made for rainwater to be carried from the roof of the building. 2. Paved areas around the building shall be so constructed as to be adequately drained. Point 3. Rainwater from a system provided pursuant to subparagraph 1 or 2 shall drainage to one of the following listed in order of priority. A. An adequate soakaway or more other adequate infiltration system, or where that is not reasonably practicable, a watercourse or where that is not reasonably practicable, a sewer. Requirement H3.2 applies only to paved areas. A. Which provide access to the building pursuant to requirement M1 access and use, or M1 access to and use of buildings other than dwellings. Requirement M2 access to extensions to buildings other than dwellings. Or requirement M4.1, 2 or 3 access to and use of dwellings. Point B, which provide access to or from a place of storage pursuant to requirement H6.2, solid waste storage, or C, in any passage given access to the building, where this is intended to be used in common by the occupiers of one or more other buildings. Requirement H3.3 does not apply to the gathering of rainwater for reuse. Requirement H4, building over sewers. Point 1. The erection or extension of a building or work involving the underpinning of a building shall be carried out in a way that is not detrimental to the building or building extension, or to the continued maintenance of the drain, sewer, or disposal main. Point 2. In this paragraph, disposal main means any pipe, tunnel, or conduit used for the conveyance of effluent to or from a sewage disposal works, which is not a public sewer. Point 3. In this paragraph and paragraph H5, map of sewers means any records kept by a sewerage undertaker under section 199 of the Water Industry Act 1991. Requirement H4 applies only to work carried out A. over a drain, sewer or disposal main which is shown on a map of sewers, or B. on any site or in such a manner as may result in interference with the use of or obstruction of the access of any person to any drain, sewer or disposal main which is shown on any map of sewers. Requirement H5, separate systems of drainage. Any system for discharging water to a sewer which is provided pursuant to paragraph H3 shall be separate from that provided for the convenience of foul water from the building. Requirement H5 applies only to a system provided in connection with the erection or extension of a building where it is reasonably practicable for the system to discharge directly or indirectly to a sewer for the separate convenience of surface water which is shown on a map of sewers, or B. under construction either by the sewage undertaker or by some other person where the sewer is the subject of an agreement to make a declaration of vesting pursuant to section 104 of the Water Industry Act 1991. Requirement H6, solid waste storage. Point 1. Adequate provision shall be made for storage of solid waste. 2. Adequate means of access shall be provided. Point 2a, for people in the building to the place of storage, and B, from the place of storage to a collection point, where one has been specified by the Waste Collection Authority under Section 46, Household Waste, or Section 47, Commercial Waste, of the Environmental Protection Act 1990, or to a street, where no collection point has been specified. So this is it. Are you still here? Excellent. Let's move on to what does all that mean to Secretary of State. Like with all the other requirements following Regulation 8, nothing more needs to be done than assuring reasonable standards of health and safety in all requirements that deal with such issues. However, paragraph H2 is excluded as it deals with the prevention of the contamination of water. It really goes without saying, but I will repeat that anyhow. The quality of workmanship should follow the current standards and the due consideration for the health and safety of people laying the drains or working in confined spaces. This matter should be fully addressed before the work commences or during the work. So now off to the requirement H1 that deals with foul water drainage. In section 1 of the document we will find out what the expectations are for the system. The Secretary of State is happy the requirement is met as long as the outflow of the water is addressed properly. The system is so designed to minimize blockages, leaks, floodings, and can be cleared of blockages, and the ingress of foul air into the building is prevented. The system should have sufficient capacity, which will depend on the size of the pipes used and the gradient, and the document provides the minimum requirements. The reading of the document deals with the domestic building and small non-domestic buildings. Appendix Appendix A deals with larger buildings, but for complex situations outside of the scope of this document, we are referenced to use guidance of British Standard European Norm 12056. The information here provided assumes that periodically there will be at least 5 liters of water flushed through the system. The document requires all discharge points to be fitted with a serviceable trap to prevent foul air from entering the house. The retained water seal should be at least 25 mm, but it is generally higher in line with the document and increases in value at with the diameter of the trap. So for toilets, or rather trap diameters of 65 mm and over that, the water seal is 50 mm, and below that it's 75 mm. There are some exemptions and easing of the requirement if there is another trap along the way, like a galley. The limitation on the location of the branch pipe discharge is in terms of discharging to open hoppers. Otherwise, discharge into another branch pipe, galley, stack or drain is perfectly okay. In case of the direct drain connection, such needs to be from ground floor appliances, and the water closet floor cannot be higher than 1.3 meters above the invert level of the drain. Branch pipes should not cause a cross flow to happen. Connection of branch pipes to stacks on opposite sides at the same level is prohibited, and the minimum offset dimension is given in the document. The offsets are taken by center line of all drainage runs, and are between 110 to 250 millimeters, depending on the branch pipe diameter and the stack diameter. Solid waste branch pipe manifolds can be used instead. It should be noted that a branch pipe connecting at the lowest point needs to be at least 450 millimeters above the invert level of the drain at the bent tail for buildings under 3-story height. 750 millimeters up to 5 stories. For taller buildings, or where the minimum cannot be achieved, the discharge should be either direct through its own stack or to a galley. Interestingly, similar provision will need to be put on the discharge from first floor appliances in buildings over 20 stories in height. Branch pipes can discharge to a substack, and the condensate from the boiler can also discharge through a sanitary pipework, but needs to be washed over by discharge from other appliances due to the lower pH of water that can otherwise damage the pipe. So either directly into an internal stack or downstream of the sink. Size, length, gradient, connection angle, and the number of appliances possibly connected to a branch pipe is covered in the document, and it accounts for not breaking the water seal due to suction in advented branch, which happens when the whole block of water passes through the pipe, causing a void, being a seal, sucking all of the air behind it as that part of water passes through the pipe. Vented branches can service longer lengths, but problems with sedimentation or noisy runoff may become an issue. Ventilation should be provided maximum 750 millimeters down the drain runoff and to a higher level than a possible spillover level. If the ventilation goes outdoors, it should extend at least 900 millimeters above any opening within 3-meter radius. When it comes to stacks, all should discharge to a drain with a bottom radius as large as possible, but not less than 200 millimeters at the center line. Offsets, or in other words bends in wet portion of the stacks, are discouraged, but if needed, then in buildings up to 3-story, any branch connected Any branch connection needs to be minimum 750 millimeters away from the offset. In taller buildings, the offset may need ventilation at its top and bottom. Stacks in taller buildings should be kept inside the building. Stacks should be ventilated and of the right size. Stub stacks are allowed, observing the maximum toilet connection height from the drain tail and the maximum height of the highest branch center line to the drain or connection center line of 2 meters. The termination of the ventilation stack should be 900 millimeters above any opening within 3 meter radius and protected with a termination cage. The stack should be serviceable and have rodding access where necessary. Many different materials can be used for the provision of discharge piping, but the choice should be well conceived and installation done properly, capable of withstanding an air tightness test simulating a pressure of at least 38 millimeters on the water gauge for at least 3 minutes, whilst all traps need to maintain the 25 millimeter water seal. Going into section 2, which covers drainage outside of the building but before it meets its further destination. Public sewer, cesspool or wastewater treatment system, the house drainage can be separated for foul water and rainwater, or combined. The foul drainage should be connected to the public system whenever possible and when it is within reach, no more than 30 meters away from a small development. We should rely on the gravity to do the work for us, but pumping may sometimes be required. Larger developments may require to go some distance in order to connect the development to the building undertaker, which may mean going through the curtilage of other lands. The developer may requisition the sewer from the undertaker who has the power to construct sewerage over private land. If possible, it should be attempted to connect to the existing private sewer that in turn connects to the public system. In any case, 3 weeks prior notice to the day of the intent for connection should be given to the local undertaker. If there is no possibility of connection to the public sewer, a cesspool or water treatment system may be required. Combined and rainwater drainage is designed to surcharge and may flood your house, especially at low-lying sites or where the basement is below the level of the drainage. To mitigate on the possible foul water flooding of your house, it is required that in the low-risk areas a provision of no-return valve is considered. Flood water can discharge through a gully that is at the level lower than the house, or that the drainage from that area of the house prone to flooding or entire house is pumped. The non-return valve should be suitable of a double valve type, capable of being locked manually, and the house occupant should know of its location and how to operate it. The drainage unaffected by a surcharge should bypass the protective measures on discharge by gravity. Layout of the drain system should be simple, as straight as possible, ventilated and maintainable, and the access points provided where the blockages cannot be cleared otherwise. Connections to other runs should be made oblique or in the direction of the flow using prefabricated components. No duct-type magic, please. Change of gradient will require an access point. Access points will also be required close to the bend or at the bend location. The drainage serving commercial hot food kitchen should be fitted with a grease separator or otherwise capable of removing grease. Measures controlling rodent movements may be necessary in the system. Drainage can run under the building if it is laid in at least 100 mm of granular or flexible material and should not be suitable to the forces exerted by the house on the ground, as well as due to settlement movement of the house. Wherever pipes go through structures, use rocker pipes both sides of the structure with flexible joints and or provide at least 50 mm of space around the pipe so that the building can move without breaking the pipe. Naturally, all such perforations need to be sealed. If the drainage needs to be lower than the foundation formation level, and within the meter of it, it should be concreted into the level of the foundation's formation. Otherwise, to the level below the formation level of the distance minus 150 millimeters. Basically, as you move away from the foundation, but not to go past the 45-degree angle, minus 150 millimeters. You will not need to concrete in your pipes. If we need to account for loading on pipes for whatever reason, we are guided to seek help elsewhere. There are no special provisions for the depth of the pipe cover, but whatever it is, the pipe needs to be protected. It also needs to be at a certain gradient to service the load it is being subjected to, between 1 in 10 to 1 in 150, but usually kept in between 1 in 40 to 1 in 80. So per every meter is either 25 or 12.5 millimeter drop, inch and a half inch in old money. The size of the sewer should be at least 100 millimeter up to 10 dwellings and 150 millimeters above. For drainage of all but the foul water, the pipe can be as small as 75 millimeters. However, if the system is combined, we also need to account for the rainfall in sizing of the pipe. Whenever we need to use pumping installation, we are referenced to BSEN 12050, wastewater lifting plans for buildings and sites, principles of construction and testing, BSEN 12056, gravity drainage system inside buildings, and BSEN 752, drain and sewer systems outside building. When we use the pumping, the chamber receiving the effluent needs to be capable of receiving 24 hours of inflow at the minimum of 150 liters per person per day. It follows the water usage cap and then some. All types of pipes can be used underground, including an all-time favorite vitrified clay, but also concrete, grey iron, ductile iron, as well as the flexible types made of plastic. This should be flexibly jointed and in no case protrude into the flow of sewage. The bedding and backfilling will depend on the depth of excavation, size and strength of the pipe. Local undertakers generally concrete their installations in, but we can go lighter on our installations. Concrete installation will require a movement joint with compressive board formed at the junctions. The bedding and backfilling material for pipes follows the mitigation of pressure points on the pipe that could break it. So uniform material with no vegetation, stone larger than 40 millimeters, lumps of clay over 100 millimeters of frozen material is generally considered good enough. In most cases, however, you will find this laid on some type of granular material, either single size or graded from 5 millimeters to 40 millimeters. Depending on the diameter of the pipe, 10 millimeters for 100 millimeter pipes to maximum dimension used for pipes over 600 millimeters diameter. Minimum and maximum ground cover for different size pipes of different types in different situations is given in the document, starting a minimum 600 millimeters for fields and 1.2 meters otherwise for rigid pipes, and slightly lower 0.9 meter for thermoplastics. Pipes laid at shallower depths will require a bridging slab over them, with a layer of compressible material between the pipe and the slab. To maintain and service drain access points need to be introduced in the system, and the guidance interprets the reasonable spacing and placements of such. Rodding eyes, access fittings, inspection chambers, and manholes are typical points that could allow rodding. The guidance considers rodding in the direction of flow only. The placement of such needs to be considered at head of the drain run, bend, change of gradient, change of pipe size, and junction if it can be rodded from one side only. Type and spacing of these access features is guided by the document and depends on the depth of the invert level and the size of the pipe. Spacing of the access points between 12 and 200 meters depending on the type of access used. 12 meters from the start of the drain to 200 meters between man-entry sized drains and sewers. The material used for the formation of access points follows the material used for the pipes themselves. The junction of pipes in the inspection chamber should follow the direction of flow. Covers to access features should be appropriate for the location. Airtight and durable. May need to be lockable also. The guidance requires metal steps in deep manholes. However, current practice prefers steps to be brought with the plumber due to the possible corrosion of the fixed steps and surprised fall of the personnel. The work of laying the pipes, connections and forming inspection chambers or manholes should be of the appropriate quality. If piling takes place close to the pipes may need to be exposed temporarily and piling should not take place too close to pipes, meaning a minimum of 2 times the diameter of the pipe to the nearest diameter of the pile to the nearest pipe. The gravity drain and private sewer systems should be tested following the construction. We are allowed to choose between a water or air test. Air test for pipes up to 300 mm diameter will be loading the system with the pressure of 110 mm on the water gauge for 5 minutes, with an addition of 100 mm of pressure for the next 7 minutes. Max drop of pressure being 25 mm of water. Water test entails filling the system with water to a level of maximum 5 meters over the lowest invert level, but to a minimum of 1 meter over the highest invert level. Such filled system is then left for an hour to prime the system, then topped up to be within 100 mm of the required level. The system is fine if the loss per square meter of surface area does not exceed 0.15 liters for pipes only, 0.2 liters for pipes and manholes, and 0.5 for manholes only. The guidance further references us to alternatives of BSEN 1091 vacuum sewerage systems outside buildings or BSEN 1671 pressure sewerage systems outside buildings. Both standards are now withdrawn. Now, although there are no building regulations requirements to maintain the drains, the local authority and the undertakers have far more reaching rights that may include inspection of your drainage system and order for repair, sealing of all drainage or its removal. Similarly, with the repair and alteration to drains, a 1-day notice needs to be given to the local authority unless it's an emergency. Another important thing to keep in mind is the adoption of sewers. Basically, under Water Industry Act 1991, Section 104, agreements to adopt sewer or sewerage disposal works at future date, you build the infrastructure for the undertaker to take care of. Certain standards of work needs to be met, but these are generally available and can be agreed upon with the undertaker. Single dwellings do not fall under the consideration. Requisition of sewage, Section 98 from the undertaker, may be the only way to connect your development to the building sewer when other curtilage stands between you and them. Under Section 102, existing drainage may be adopted if it meets the criteria, and the adoption may proceed from the developer's inquiry or on the undertaker on volition. Section 106 gives the right for the connection to public sewer with a 21-day notice upon agreeing on the technical details of such connection. Section 107 gives rights to the undertaker to carry out work or choose to supervise the developer's work. Section 112 means the undertaker can request the manner in which the sewerage is constructed for the general system of drainage, reimbursing the developer for the extra cost. Drainage may be also adopted by Highway Authority under Highway Act 1980. It is possible but discretionary that the highway drainage becomes part of the building surface water drainage. The requirement H2 deals with wastewater treatment systems and cesspools. The Secretary of State is happy if the systems are of the right capacity to do the job and be seated so not to cause nuisance or health hazards, pollute control waters or water sources, or be in flood-prone area. They should have enough ventilation and not allow groundwater ingress or allow groundwater to overload the system. Information on maintenance should be available in all service buildings. The typical course of action prior to the specification of the wastewater treatment system is the permission of the Environment Agency, typically as a part of the planning permission process. The guidance makes reference to BS 6297 Code of Practice for the Design and Installation of Drainage Fields for use in wastewater treatment for the detailed design of these. Septic tanks or septic tanks with secondary treatment in drainage fields, mound or wetlands are typical solutions for one to several dwellings. The basic idea is for the solids to settle in the tank and the water to soak into the ground and any bacteria to decompose in the aerated soil. Package treatment works do what they say on the tin. Same with the septic tanks with secondary treatment, but in a compacted version allowing direct discharge to the watercourse. Economic for larger developments. Cesspools are just storage vessels for sewage, so will generally not be permitted unless no other way is feasible. Now, septic tanks need to be positioned at least 7 meters away from any habitable parts of buildings and be readily available for emptying, meaning not further than 30 meters from the vehicular access for septic tanks, with an invert level not deeper than 3 meters. The tank needs to be at least 2.7 cubic meter of capacity under the inlet for four users and additional 180 liters per person. Tanks can either come from the manufacturer but can also be constructed in engineering brick using 1:3 cement to sand ratio mortar or 150 millimeters of thick concrete at least 25 newtons per millimeter squared strength. Ventilation, further requirements for the avoidance of settlement or scam disturbance, controlling the amount of inflow and access for testing of inflow and outflow, as well as for emptying. The access for emptying should be secured and durable. The information for the type of sewage treatment and maintenance requirements should be fixed within the building. A drainage field should be at least 10 meters away from the watercourse or permeable drains, 50 meters away from points of groundwater abstraction or Zone 1 groundwater protection zone, minimum 50 meters from any building and away from other drainage features. Further expectations are put on the location and quality of the ground conditions and its capacity to soak in water, so a percolation test will be required at least 3 times within at least two trial holes. The design generally follows the spread within perforated pipes over a bed of granular material, similarly with the mound. To calculate the floor area of the drainage fields, we need to multiply the number of people using the system by the percolation value in seconds per millimeter divided by 4. Reeds beds are also a possibility for the secondary or tertiary treatment system and will be of 2 types, either horizontal, spreading the water in one plane, or vertical, allowing the water to permeate evenly through the layer of the reed bed. The document refers to BRE Good Building Guide number 42 for the design and construction of reed bed treatment systems. In the area of nutrient neutrality influence, the reed beds may be one of only possible alternatives for the development. According to the document, package treatment works should be in accordance with BS 7781, which is now withdrawn. Discharge from the plant should be at least 10 meters away from watercourses or buildings, and it should work even in case of a power outage for up to 6 hours at least. Cesspools limits are similar to limits of septic tanks, but capacity needs to be much greater, at least 18 cubic meters for 2 users, with an additional 6.8 cubic meter for every additional person. Grey water and rainwater storage tanks for reuse in the house should be contained and isolated from the ingress of groundwater and protected from backflowing of sewage into the tank through the outflow. Similarly, with the previous requirement, local authorities and undertakers have overreaching rights to make sure the systems are safe and well maintained, and our waterways are not polluted. It is, however, an entirely different matter if they are using these rights or not. The requirement H3 deals with rainwater drainage. For the Secretary of State, it is enough to carry the water properly away from all the roofs and paved areas, making sure the system can be cleared of blockages and so it does not damage the foundations of buildings or structures. The preference of the outflow given to soakaway, then watercourses, then sewers. The sizing of the rainwater system will depend on the area of the drain surface and envisaged rainfall, and can follow the prescription of the approved document or to be in line with BSEN 12056, gravity drainage systems inside buildings. The flat area will be treated as a tributary as it is, but inclined planes will have a factor applied to planar area that takes in consideration driving rain. So for 30-degree pitch roof, the factor will be 1.29 of the plane area. For 45-degree roof, the factor is 1.5, and for 60-degree roof, the factor is 1.85. Walls are treated as 50% of the elevation areas, and walls are considered any planes inclined more than 70 degrees. The sizing of rainwater goods then follows an assumption of level gutters of half-round nature with the max run length at one outlet of no more than 50 times the water depth. Gutter size start at 75 mm and outlet at 50 mm for the effective area of 6 meters squared, and end up with 103 mm squared for 150 mm half-round gutter with 89 mm outlet. Flow rate 0.38 to 2.16 liters per second in between these two sets. Rainfall intensity can be taken from map for Kent being at circa 0.02 liters per second, in other words less than half a teaspoon a second. Rainwater pipes can discharge to another gutter or surface, but ideally to a drain or a gully. If it drains on the roof or pavement, a shoe should divert the water away from the building, and if the discharge is of more than 25 meters squared, the water should be distributed so as not to cause a waterfall due to the overflowing gutter of the lower roof. Siphonic roof drainage should be considered using ancillary standards with special care taken due to possible downstream surcharge and time delay for the siphoning action, possibly requiring overflow arrangement. The guidance references use of Hydraulic Research Limited report SR 463 as an assistance and directs us to BSEN 12056 for further information. Eavesdrop system is allowed, provided due considerations to the effect of falling water, and harvesting system when introduced should be clearly marked. Material for use in rainwater goods should be suitable, watertight and firmly supported, but allowed to expand and contract due to temperature changes. For pavement drainage up to 4,000 meters square, we are directed to the following guidance. The waterfall considered is lower than that for roofs, and now in Kent at 0.016 litre per second per meter square, around third of the teaspoon. The map gives values for different parts of the country. The surface should be graded towards outfalls and away from buildings. Gradient of at least 1 in 60 in general and max of 1 in 40 across a path should be used. Naturally, outside of the simple directions, we are guided to BSEN 752. Whenever possible, the paved areas should be draining free to pervious areas. It is being encouraged that a pervious paving is used wherever possible. The design of such will follow similar consideration to that of soakaways. If the ground beneath the paving is impervious, the granular layer or crete system can be used as an attenuation tank. For more details, we are being sent to Syria C522 report, Sustainable Urban Drainage Systems, Design Manual for England and Wales. For areas that cannot soak the water in drainage, should incorporate gullies with appropriate catch pits for silts and position so as to accommodate the settlement of pavement. Guidance says 5 mm below the pavement. The pavement drainage covered within the document is for the area larger than 2 hectares, that is 20,000 meters square. As ever is practicable, outlets should lead to soakaway, watercourse or sewer, with the last resort in connecting to combined sewer. But in any case, the capacity needs to fit the combined flow charge. The capacity chart is given in the document relevant to the size of the pipe and its gradient. Contaminated runoff will require separate drainages, and the runoff from petrol stations and car parks should be provided with oil interceptors. Serial Report 156 Infiltration Drainage Manual of Good Practice, BSEN 752 and blockages 365 Soakaway Design are the references for dealing with the infiltration systems, but some simple directions are given for small area runoffs. In addition, swales, infiltration basins, filter drains and detention ponds are encouraged. The requirement H4 deals with building over sewers. In the gist, to satisfy the requirement in the eyes of the Secretary of State, the proposed work as of during the construction and as standing cannot damage the existing drainage system or obstruct access to its inspection points. The structure should be so built to not obstruct future replacement works, usually meaning at least 500 mm away from the walls in case of shallow drains. Moreover, the building should not be susceptible to drainage failures, which in practice often means bringing the depth of the foundation formation level to that of the drainage system. This requirement is valid for building work at 3 meter distance from the center line of the drainage. Drainage is identified on the undertaker's asset maps, but often when it comes to lateral disposal mains, these are not on maps. However, the provisions of this guidance will still be valid and gaining the local undertaker approval for the proposed work necessary. The local undertaker will likely need to confirm the condition of the existing sewer for reasons of possible need for replacement and to make sure the work do not damage the drains. The guidance points our attention to the fine granular soils which may settle due to the washing away of fine grains into the sewer in case of damage to the drains, and groundwater infiltration which will carry these fine particles away. We are also reminded of a possible collapse of drains and the impact it may have on our buildings. Internal inspection chambers for more than one property are a no-no, as the access for maintenance needs to be readily available. An alternative external provision approved by the drainage owner, typically a local undertaker, would be a way forward. A satisfactory diversion possibility needs to be allowed for such that can allow a reconstruction of a sewer without affecting the building. The Secretary of State claims 3 meters of the building to be the right distance and requires mechanical excavator access for drains below 1.5 meter deep that could be excavated using such machines. The guidance limits the length of the build over sewer to 6 meters, however other agreements can be reached with the owner of the system. Another 3 meter limit exists on buildings nearby or over drainage system that is more than 3 meters deep or greater than 225 millimeters in diameter. As ever, speak to the owner first, as other agreements can be agreed on. Doing the works near or over the drain line should minimize the impact on the drain, and piling cannot be done closer than 2 times the pile diameter of the pile, and if the piling takes place within a meter of the drainage, such should be exposed. Settlement of the building should be addressed in the drainage construction, allowing for differential movements. Excavation for drain trenches should not undermine existing foundation, and if the drain is deep enough according to guidance, 2 meters to the invert level, then the foundation should form a lintel over the drain with 1.5 meter span either side of the drain, and designed so no loads is transmitted onto the drain or sewer. The requirement H5 deals with separate systems of drainage. There is not much here to convey really. The foul or great water should not mix with rainwater. For one, the sewage treatment work does not need that extra water from rain, and poop floating on our streets due to the flooding is not an ideal scenario. The rain can be either soaked in the ground locally or discharged to the local waterways instead. When there is work taking place splitting the combined systems, the new development drainage system should be separate and accommodate the future connection to the separate system. To deal with contaminated runoff, agreement with the local undertaker needs to be made first. The requirement H6 deals with solid waste storage. In the Secretary of State opinion, as long as the storage is safe and not prejudicial to amenities and agreed with the collection authority to the size and placement, the requirement is satisfied. A few general points to consider here. Storage space for storage containers needs to be provided. Containers of 250 liters, 0.25 cubic meter capacity per dwelling per week. For domestic developments up to 4-story, access to 2 separate movable containers in line with the local requirements needs to be provided. For separate storage areas per dwelling, an area of 1.2 times 1.2 meters should be sufficient. Communal storage areas will require consultations with the local waste collection authority. In high-rise domestic buildings, up to 4-story dwellings can have separate storage areas and the rest can have a chute-fed system in place or another suitable arrangement. The distance the householder has to travel to get to the storage areas should not exceed 30 meters horizontally and the waste collectors 25 meters. For containers up to 250 liters, up to 3 steps on the way to the collection point are allowed and slope should not exceed 1 in 12. External storage areas should be away from windows and ventilators, preferably in shade and under shelter. NHBC Foundation Report NF60 gives some further guidance. Storage enclosures should allow 150 mm movement around the container, be ventilated top and bottom on a paved surface and high enough to open the lid for filling. Minimum 2 meters high for communal storage and should be protected from vermin. Areas should be washable and capable of receiving polluted effluent with a trap prolonging seal in dry periods. Storage rooms should be separated for recyclable waste. Storage chutes should be ventilated at least 450 mm in diameter with closed access fitting at each story, and its surface should be smooth and non-absorbent. We are also told the BS 5906 Code of Practice for Waste Management in Buildings is a valid alternative approach. Abiding by the requirement, it usually means consultations with the local waste collection authority to establish the requirements and to be on the right side of the Environmental Protection Act 1990, especially when the circumstances are more complex and the waste is more hazardous than is the typical domestic case. So do it right and segregate your waste as required, whether you are a homeowner or run a commercial gig. So this is it, folks, the approved document H, drainage and waste disposal. Let's sum it up. The Secretary of State expects that the standards for health and safety are reasonably met. This responsibility excludes paragraph H2, which pertains to water contamination prevention. In summary, requirement H4 to H6 emphasizes the importance of not only meeting technical specifications for drainage and waste storage, but also ensuring the systems are safe, accessible, and environmentally sound. Collaboration with local authorities and adherence to guidance and standards are essential components of compliance. Requirement H1, foul water drainage. Designs needs to ensure the proper capacity of outflow, minimize blockages, leaks and flooding, and prevent of foul air ingress into buildings. Systems must pass an air tightness test simulating the pressure of at least 38 mm on the water gauge for a minimum of 3 minutes. Requirement H2 that deals with wastewater treatment system and cesspools. Energy systems must be of the right capacity and location to avoid nuisance, health hazards and pollution. Have adequate ventilation and prevention of groundwater ingress. Following guidance from the Environment Agency and adherence to BS standards for design and installation is a good idea. Clear information on maintenance requirements should be available. Systems must be periodically monitored and maintained to prevent pollution and health risks. Requirement H3 rainwater drainage means that systems must carry water away from roofs and paved areas. Preference for outflows should be given to soakaways, then watercourses, and lastly, sewers. Correct sizing is based on drainage surface area, rainfall expectations, and the rate of infiltration. Systems should be simple, maintainable, and allow for adequate access points for clearing blockages. Requirement H4 deals with buildings over sewers. We need to ensure that new building works do not adversely affect existing drainage system, obstruct access for maintenance, or create future problems for building stability due to drainage failures. An agreement with the owner of the drainage system will be needed. Requirement H5 separate systems for drainage. The drainage of surface water and foul water drainage should be kept separate to prevent contamination and facilitate effective drainage management. New developments should have separate systems for surface water and foul water drainage. Surface water should ideally be directed to soakaways, watercourses, or surface water sewers. Local authority approval is required when using combined systems, ensuring that public health and environmental standards are met. Requirement H6 solid waste storage is in place to ensure that buildings are provided with adequate facilities for storing solid waste before it is collected, preventing health hazards and maintaining hygiene. Building must have suitable and sufficient space for storing waste containers, bins, bags, etc. based on the building size and use. Waste storage areas must be easily accessible for both occupants and waste collectors. Storage areas should be located to prevent health hazards and nuisance, ensuring they are not placed too close to habitable areas. Waste storage facilities should be designed to be vermin-proof and weather-resistant. Adequate ventilation and cleanliness must be ensured to prevent unpleasant odors and pest infestation. In the next episode, we will move to approved document J, combustion appliances and fuel storage system. I hope you enjoyed this episode and that the consideration of the approved document H drainage and waste disposal makes more sense to you. It's been a long one, but I decided not to split this one in parts. I think in this circumstance it's better to have it all in one place. If you have any questions, reach out to me on LinkedIn or send me an email. I am more than happy to help you out. In Bytna, we deal with planning, designing and managing of your projects, and we are always glad to facilitate a free initial consultation to steer you in the right direction. Visit www.bytna.co.uk and reach out to us. Whether your question is if we can help you with your project or what should I do, we will be able to give you a piece of non-obligatory advice. At Bytna, we help our clients design and execute their dream homes or investments. If your building is falling apart, we can also help investigate the reasons behind it and to provide you with an appropriate strategy, design and specifications for the repair. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. See you next week. Bytna designs the world around you. Toodaloo.